All right, here's our last example. The city runs 3 triangular bus routes to various attractions. How can you draw a separate triangle for each route? Are any of the routes the same length? Okay, well let's take a look and see what we can figure out. So we have the green route. The green route starts at the Science Museum and goes to the theater. So I am just going to track the green route. So from the Science Museum to the theater, then, and I'm just reading, here's the route over here. After the theater, they head to the History Museum. Great. From the History Museum to the zoo. From the zoo to the Rose Garden. And from the Rose Garden back up to the Science Museum. So we can see that the green route forms a triangle with a right angle right here. So we do have a right triangle. So why don't we redraw that right triangle below the green route? Looks like this. It's a right triangle. And let's see, what are some of those measurements? If we add up, we have 0.9 plus 1.2 gives us 2.1. We have 2.1 plus 1.4 gives us 3.5. And we don't know anything about how long that is, so we have that information. All right, let's check out our purple triangle. I'm going to go ahead and erase the green route just so I don't get it confused with anything else. Let's go for purple. All right, the purple route starts at the water park and goes to the art museum. So we're heading this way. Here's our purple route. After the art museum, we're going to the concert hall. After the concert hall, we're heading up to the science museum. After the science museum, we're heading to the zoo. And after the zoo, back to the water park. So I'm just going to redraw that below like we did on the last one. If we add up our side lengths, over here on the left we have a 3.9. On the right we have a 4.4. And along the bottom we have a 2.9. And again, that's me just adding up these distances that are on this route. All right, now I'm going to erase the purple route and we're going to do the red route. Red route starts at the football stadium and goes to the zoo. So football stadium up to the zoo is this direction. After the zoo, we go to the theater. After the theater, we go to the Rose Garden. Nope, we go to the Science Theater. And then we go down to the Rose Garden and we go to the football stadium to tie that back together. So let's draw that one. This one looks like from here to here. Maybe not quite that far. And then to here. We have a right angle in this one. And those distances, we have a 2.1. If we add up these segments going straight down, that's going to give us 3.5. And the third side from here to here, well, we don't know what those are. Okay, so now that we understand what's happening in the picture and we have some more detailed routes with distances below, what were our questions again? How can you draw separate triangles for each route? Well, we just did. We just found each route, we drew the separate triangles below, and we tried to figure out how long the segments were if we had enough information. Are any of the routes the same length? So what that means is if you were to add up going around, add up going around, add up going around, do you get the same distance around each triangle? So of course we get to apply something that we learned in this chapter. If we look at our routes over here, here's a right triangle, here's a right triangle. When you have right triangles, if the hypotenuse is congruent and one of the legs are congruent, you have congruent triangles by the HL postulate. So let's check to see if we have any congruencies. Looks like we have a side length of 2.1 and a side length of 2.1, so those are congruent. Looks like our hypotenuse of 3.5 is congruent to this hypotenuse of 3.5, and we have a right angle in both triangles. So when you have right triangles with a congruent hypotenuse and leg, then you have congruent triangles. So the green route and the red route are congruent. Now, I don't know what this third side is right here, but I know that if the triangles are congruent, maybe let's make a note off on the side, they were congruent by the HL postulate. That means all corresponding parts are congruent. So I know that this side will be congruent to this side because my triangles are congruent, CPCTC. So the route going, or the distance taking this route and the distance taking this route will be the same.